I'm Sabrina Ramonov, and in this video series, I explore LLM-powered AI agent pathfinding. And the reason why I'm working on this problem is because my goal over the next couple of months is to build from scratch a multi-agent village simulation, similar to AI Town. And agent pathfinding is a really important part of the simulation. So imagine an agent in the simulation wants to go visit their friend's house across town. Pathfinding is what enables them to figure out how to get from their own house to their friend's house across town. And so that's why I'm working on this problem. And you're going to see, like, for example, on the screen, we have this little guy kind of bopping around the different squares. Each black square corresponds to a 0. So the agent's not supposed to be able to walk into a 0. That could be like a wall or a locked door or like a tree or some other kind of obstacle. And then a 1 square, that's the colored orange squares you see here. Those are valid places where the agent can move. So like a road or grass or something where the agent can walk freely. And in this video, I'm going to show you kind of the prompts I'm working on for agent pathfinding, starting with a really naive prompt, making sure that the agent can recognize where to go versus not go. So here's our code base to test pathfinding. And basically what we have is a 3x3 grid or matrix with 0-based indexing. So starting from the upper left corner, if you want to go down, this is coordinate 1, this is x equals 2, y equals 0. If you want to go here, this is x equals 2, y equals 0, 1, 2. Okay, so it's 0-based matrix coordinates. And to keep it really simple, we're going to start with this grid of 3x3, everything 0, and then I'm going to flip one of these into a 1. And since it's like a 2D pixel game simulation, only these 4 squares can be flipped into 1. So you can think of it as like the agent is in the middle here, and they can only go up, down, left, or right. So only those values can be flipped to a 1. So here's the prompt I'm using for this kind of naive pathfinding. You're given a 3x3 matrix, find the coordinate that contains the number 1, and return it in the format row and column. And then I have a test suite as well. I also built a little parser to extract the row and column from the LLM output, which you can see here on the right. This file basically shows like the latest runs when I run the test set. So here's the prompt, and then for example, the LLM might output something like this with a bunch of extra words and characters I don't want. So I have a little parser, just use a simple regex to extract the coordinate in exactly this format, which is what I need for the rest of my simulation code. And then here I'll show you real quick how we actually test. So here, this is taking this prompt and then processing 3 samples, and then you can see the accuracy rate is 100%, which is great. But you know, when I test on a much larger sample size, the accuracy is usually quite far from 100%, which is why I'm working on improving the prompt. So let's actually try this existing prompt on a bunch more samples. Let's try it on like, I don't know, 20 samples and just see what happens. Yeah, so you can see here, exactly as I mentioned before, it had 100% accuracy on a sample size of 3, which isn't like super meaningful. And then when I increased the sample size to 20, the accuracy dropped to 65%. And so in this video, I'm just going to literally like film myself iterating on this prompt until we can improve the accuracy substantially. So the first thing I want to do to figure out how to improve the prompt is look at what it got wrong. So again, this log file updates with the last run. The first sample is already incorrect, so let's see what it did here. So the correct answer here is 1, 2, but the LLM outputted 2, 2. So that's incorrect. That one was correct, correct. I'm looking for the ones that are incorrect. This is also incorrect. So the correct answer again is 1, 2. The LLM returned the output 2, 2. So the first thing I want to try is limiting the possible options it could be. So remember at the start I said we're really trying to keep it simple here. The agent starts in the middle and it can only move up, down, left, or right. So those are the only squares that can be flipped to a 1. Here in my prompt, I don't have any limitation of that. Like it can't move diagonally here to 2, 2. It can't move to 0, 0. It can't move to 0, 2, and it can't move to 2, 0. So let's try incorporating that in the prompt. let's just check that's correct. So 0, 1 responds to up, 1, 0 corresponds to left, 1, 2 corresponds to moving right, and then 2, 1 corresponds to moving down. So thank you, GitHub Copilot. And let's go ahead and run this. Okay, I mean, the accuracy is a little better, 70%. I wouldn't say it's substantially better than the previous run, because the extra one that it got right could be a fluke. So it still seems to be, for example, here where it's false, it still seems to be outputting coordinates that are not in the list. So 2, 2 is not in the list, but it outputted it anyway. So maybe our instructions weren't super clear. Let's say if the coordinate is not in the, I don't want to return an error, but thanks, Copilot. I'd say, okay, 80%. Did maybe it tried again. All right. Okay, I'm looking for one that's false. So for example, here's a sample that is false. The correct answer is 0, 1, but it outputted 1, 0. It sees that the 1 is located at the second row and first column, which is just wrong, which is interesting. So it really didn't even recognize the correct location for the 1. And so this makes me wonder if we should try chain of thought prompting and really break it down into multiple steps. So let's try that here. So your first task is to find the coordinate. Okay. Let's all make that part of the first task. See how that works. Your second task. Actually, let's not make that the first task. Let's make a first task like just take a deep breath and analyze the matrix. So your first task is to analyze the matrix. Let's say using zero-based indexing. I don't know if that will help it kind of like recognize the correct row index and column index. We'll see. Okay. Your second task is to find the coordinate. I don't know if I like the word coordinate here. If we're using matrix, does it make sense you say like matrix entry? Or I don't even know if I like this. We could do like row, a column. Yeah. So row, column must be one of the following. If the row column is not in the list above, try again. Maybe we should make that an explicit task. Like your third task is to check. Your third task is to check that, the row and column is one of the following. So your fourth task, if the row and column is not in list above, maybe we should be more explicit about what it means to try again. I want to be as explicit as possible, so I'm going to say try again to find the row / column containing the number 1. All right, so we've got 4 tasks so far, and then let's just clarify that its final task is to return the let's just say row and column. And let's see how that does. I'm going to remove this coordinate at the end Just don't want to confuse it. And even if this accuracy ends up being lower, I wanted to do chain of thought just to see what it's thinking, and maybe that can help us create an even better prompt. All right, it's done, and we see an accuracy of 80% with 10 samples. So let's go ahead and look at the ones that got wrong and try to understand its step-by-step reasoning. So here's the prompt. Okay. Interesting. So it did analyze the matrix. It recreated it, which I didn't ask for, but that's great. Find the row. The number 1 is located at row 2 and column 1 using zero-based indexing. Yep, since the found row is 2, 1, oh, interesting. So this is where it messed up. So it actually located the correct square, 2, 1, and then it messed up in task 3, checking if that row and column is part of the following. The found row and column is 2, 1, but it concludes it does not match any of the given options. Okay, that's it concludes it doesn't match one of the allowed coordinates, but it doesn't try again. So it says the same row and column is still correct, and then gives that as a final answer, which is correct. This is actually the correct answer, and yet we marked it as false, so it should be true. This is really interesting too, looking at this particular sample. The LLM starts generating R code. And this explains why, because in my prompt I accidentally left like a capital R, and so the LLM probably interpreted that as R, the language. So that was my bad. So here's another sample that is marked wrong, and the LLM again reconstructs the matrix. It finds that the number 1 is located at row 2 and column 1, which is correct. The row... Yeah, this task 3 just seems to be very inconsistent again. The entry had found 2, 1 is in the list of allowed answers, and yet it claims it's not. So I might remove that step altogether. The problem, though, is so it returns 2, 1, which is the correct answer, but I think there's something wrong with my parser because it's marking this output as false. So I opened up the regex I'm using to extract the row and column, and basically how it works is it just looks for the first coordinate in this format, parentheses row, comma, column, and extracts it. And so sometimes the LLM output will have the correct row and column as the first coordinate in its entire output, in which case, that's when the answer is marked correct. But in this case, for example, it's marked as false because the first coordinate that this regex is finding is from my prompt, like here where I say check if row and column is one of the following, it's 0, 1. So even though the LLM actually produced the correct answer, 2, 1, my regex is extracting 0, 1 as the supposed answer, which is why it's marking this as false. So I actually was thinking of removing task 3 altogether because how the LLM is checking if the coordinate it's found is one of the following coordinates just doesn't seem correct. Like here again, we have that example where it believes the correct coordinate is 2, 1, which is correct. And it is in the list of allowed coordinates, but the LLM is saying it's not in the allowed coordinates, which is super confusing. So what I think I'm going to do is just remove that third task altogether. I do like how it's analyzing the matrix and able to recreate it. So I'll leave that there. Okay. So let's just do 3 tasks here. So first task, analyze the matrix using zero-based indexing. Second task, find the row and column that contains the number 1. Final task is to return the row and column. Okay, let's give that a go. Nice, we just got 90% by removing task 3 because it probably removed a bunch of samples that were marked as wrong even though they actually were correct. Okay, so that's pretty good so far. And if you want to see how that looks in the game, let's go ahead and open and run the game again. All right. Oh, so this little guy is actually using the latest prompt we put together, which, had 90% accuracy on a sample set of 10. You can see it's not quite perfect because he does keep falling into some of these black squares, which correspond to the zeros. But it's pretty cool to watch it kind of visually using this LLM prompt to figure out where to go. So here it's kind of bopping around, just moving back and forth, left and right. Will it be able to get out? Pause. Oh, no, it's still bopping around. But yeah, this is a pretty cool visualization, again, of an AI agent powered by an LLM trying to figure out where to go. So the next technique I want to try is called few-shot learning, and it's basically giving correct example to the LLM so that it can kind of better learn what the answer should look like or what valid answers look like. So here I'm going to say here are examples of valid answers, delimited. Oops. Delimited. Let's do triple back quotes. Oh, nice. Thank you, GitHub Autopilot. 0. So let's change these though to answers that actually are valid. So like I said before, the agent's in the middle and it can only move up, down, left, and right. Again, similar to like a 2D game you would play. You don't just like move diagonal, you move up and down, left or right. So 0, 1 would be valid. 1, 0, 1. 1, 0 would be valid. 2, 1 would be valid. Oh, thanks. Thanks, Autopilot. And 1, 2 would be valid. Okay, perfect. So these really are the only valid answers, even though I'm saying here are examples of valid answers. But let's go ahead and see if this few-shot learning helps the LLM at all. All right, so we got accuracy of 100% with a sample size of 10 just by introducing few-shot learning here, where I give the LLM examples of correct answers. So the real test will be, running this on many more samples. So I'm going to go up and update the number of samples. Instead of 10, let's say at least 100. Let's say like 200. All right, we actually got 89% accuracy, which is pretty good on 200 samples. I am curious like what it got wrong. So let's go ahead and look at the log and find some of the outputs that were incorrect. So here, for example, sample number 6, the correct answer is 1, 0. You can see the LLM was able to reconstruct the matrix. The number 1 is located in the first row and first column. Okay, so it kind of misinterpreted, i.e. row comma column equals 0, 0. That's weird that it said first row and first column and then also said it's 0, 0. So that's confusing. And then it gives the final answer as 0, 0. It wasn't correct kind of in any part of of this analysis though. So it's unclear like maybe what we could have done to help improve it. Let's try to find a different example. Okay, sample number 8, also false. Okay, here's the matrix. And it's interesting, like it is able to reconstruct the matrix. Found the number 1 is located at row 2 and column 1. Okay, so here it reconstructed the matrix correctly. It even said the right answer, row 2 and column 1. But for some reason, it gave the answer 1, 1, which is super weird because even in our prompt with few-shot learning, like 1, 1 like is not an example. So I'm wondering why it messed up the interpretation from getting the right row and column, but then for some reason it just outputted 1, 1, which is super weird. One thing we could try is give examples of wrong answers just to rule out like the diagonal movements that are not allowed. So for example, like 0, 0 is not allowed, 2, 2 is not allowed, things like that. 1, 1 is also technically not allowed because this is where the agent starts. Again, like you can think of this as a game, the agent's in the middle, and then trying to figure out whether it should go up, down, left, or right. So let's go ahead and try that. This technique is called negative prompting. You tell the LLM what not to do. Generally, it's not as effective or productive as few-shot learning, where you give examples of correct outputs. But let's go ahead and see, for our use case, if it makes any difference. So here are examples of invalid answers. Thank you. Autopilot. Okay, let's autopilot again. I mean, not autopilot. That's my car. This is GitHub Copilot with the light bulb, and I'm just literally tabbing the autocomplete because it has pretty good autocomplete. All right, I'm gonna tab again. Thank you, GitHub Copilot. And let's just double check that these are correct. So yeah, 0, 0, which is the top left corner. 1, 1 is the square in the middle where the agent starts. 2, 2 is the far corner on the bottom right. It also can't move here, like the bottom left. So this would be 2, 0 right now, but I'm trying, doing my best. That's 2, 0. Did we? I feel like we missed one. I think we didn't get this one right, so that would be 0, 2. Okay. Let's try it on a smaller sample size first. So it's 200 took a little bit of time. So let's just do a real short test real quick on like 10. Okay, 90% on 10. That seems worse because before, when we only had examples of correct answers, the accuracy was 100% on 10. Now that we've introduced negative prompting, the accuracy went down by 10%. And so I'm not super surprised. Negative prompting has been proven in research settings that it's just like not as productive as just telling the LLM what you want. And so I'm wondering if there's a more explicit way. Instead of saying, here are examples of valid answers, we could like really, really try to constrain it and say, here are the only valid answers. Here are the only valid answers. Let's see how that does. So here the accuracy was only 90%, similar to the last run. And all I did was change here are examples of valid answers to here are the only valid answers. And for some reason, the LLM performed worse. So I'm going to change it back to what we had before. Here are examples of valid answers. And remember on the run with 200 samples, and we noticed in the log that sometimes the LLM would have trouble translating the correct answer it found into the coordinates. And I'm wondering if our introduction of step-by-step chain of thought is kind of causing that issue, like it's unnecessarily introducing a step that could go wrong. And so for this next experiment, I want to try kind of removing chain of thought, kind of the step-by-step breakdown, but keeping the parts of the prompt that seem to be working well, like referring to it as a matrix, telling the LLM to use zero-based indexing and stuff like that. So let's say you were given a 3x3 matrix. Oh, no, actually was, yeah, where each element is either a 0 or 1. I don't know about element. Let's say value, where each value is either a 0 or a 1. Use zero-based indexing. Okay. So let's just give it one task. Remove these steps. Just say find the row, comma, column containing 1. We started with something similar to this, but now we can take the aspects that have worked really well and just keep those. Then give me an answer exactly like this. I don't like it when there's like a lot of extraneous text and stuff in the output, just because that could introduce something that goes wrong with the parser, since the parser is just looking for the first coordinate within the output. So let's just say x Not even sure if I should X comma Y or row call. X is the row index and Y is the... If that doesn't work well, I think I'll change, coordinate X comma Y to coordinate row comma column. And then here are examples of valid answers. I don't know if we need to give this example. It seems to be doing well, like analyzing the matrix, but this could be interesting to test if, okay, let's test it out on a sample size of 10. All right, nice. It got 10 out of 10 correct. Next step really is just to test it on a larger sample size. So let's try 100 to start with. Oh, wow. It got 99% accuracy. I am curious, like, what did it get wrong? And so this is the only sample it got wrong, sample 68. So the correct answer is 10. And then the LLM output was this. It was like, yeah, X comma Y and then 0. Yeah, so let me just like replace this with row comma column. And then hopefully I don't have to like explain anymore. Let me clean this up to is where each value is. Trying to remove like any words we don't need. You're given a 3 where each value is 0 or 1. Use 0 indexing. Find the row comma column containing 1. Then give me an answer exactly like this. Row comma column. Here are examples of valid answers. All right, let's try this again on 100. Ooh, so accuracy went down to 97% actually. So there were 3 more. So let's just see what went wrong. So here, this is false. Row comma. Oh, so this actually is the correct answer, but it doesn't have parentheses. So it literally just outputted like parentheses row column. So that's kind of confusing. Let's check anything else. Maybe that's like the main thing that that's happening sometimes. Oop. I think I checked that one already. Yeah, so similar here. Well, first of all, the answer is wrong. It's not 2. But then the second issue is that the coordinates don't have parentheses around them. So like our parser would just flag this as wrong. And so maybe this is confusing it. So here I'm going to try simplifying it even further. Return the row comma column containing 1. Ooh, and here the accuracy went down even more to 91%. And the log file changed, and interestingly, one of its outputs was Python code to find the element containing 1. And so yeah, this is so far actually the best prompt we had was the one that returned 99% accuracy. So let me just go back to that. Yeah, I believe this was it. It was like X and Y. And again, it had 99% accuracy, and the only one it got wrong was because it was missing the parentheses. But like in the next couple of variations we tried after that, like there were even more outputs missing the parentheses, so that didn't make it any better. So yeah, I mean, I'm pretty happy with this prompt so far. 99% accuracy, I think is pretty great. And let's see how it runs in the actual game. So. Okay. All right, there's our little guy moving. Oh, he keeps moving through the black squares. He's not supposed to do that. All right, here he is bouncing around the orange squares. To be fair, there's like a lot of orange squares there. All right, can he make it through this hallway? Come on, go down. Well, he hasn't fallen into any black square in a while. Okay, he moved. He's not supposed to. Okay, he moved diagonally, but okay, we'll let that go. I'm just wondering if he can make it down towards the tunnel. Oh no! So yeah, this concludes my video for kind of my first attempt at LLM-powered agent pathfinding. And again, my long-term goal is to build a multi-agent simulation from scratch without using kind of the open source frameworks out there like AI Town. Although I highly recommend you check it out if you're interested in multi-agents. AI Town is a really fun one to start with. All right, I'm Sabrina Ramonov. Thanks for watching. Drop a comment below or like this video.